I tried to imagine a fellow smarter than myself, and then I tried to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I'm your host, Jesse Lawler, here with the 24th episode of this podcast, where, well, this will probably go down in history as the viral edition of this podcast, not because it's going to get passed around the internet like crazy, but because I've got a virus. And yeah, you can hear in my nose, I've got a little bit of a head cold that I've been fighting the last couple of days, so my radio voice is going to be a little bit goobered up for this one. But luckily, when we recorded the interview a couple of days ago, that was not yet the case. But these the before and after segments, I can't promise you my best work, especially because, as we've talked about, kind of you need, in order for your brain to be functioning perfectly, you kind of want your body functioning pretty much perfectly as well. These two are inextricably linked, and that's kind of what we're going to be talking about with our guest, Dr. Fernando Gomez Pinilla of the UCLA Department of Psychological Science and the NeuroLife Laboratory, where he is one of the head researchers, and a lot of the stuff that he's been researching into has been about the conjunction of dietary health and physical activity and cognition and how all these things sort of play off of one another. So very interesting interview and a lot of takeaways as far as what you can be putting on your food plate and working into your schedule that might be worth doing for your cognition. So good stuff there. If you hang around until the end of the episode, there will be a tip related to sleep and, in fact, naps and how different types of naps are going to have different cognitive benefits for you. And depending on what you want to be feeling like on the opposite end when you pop out of the nap, just exactly how long you should time your nap for. So hang around for that. But before we get to any of those things, let's do This Week in Neuroscience.
Smart Drug Smarts. This Week in Neuroscience.
So if you remember episode 24 of this podcast, we were talking about transcranial direct current stimulation, which was basically the applying of electrodes to the outside of the human scalp, running electricity through them, and thereby giving some extra potentiation to areas inside the brain, making them more likely to have their neurons fire, and thus the cognitive sparks fly. That's making its way even into consumer technologies. There's some video gamer products that are basically allowing you to charge up your brain so you can play video games against your friends extra fast and amaze your friends, impress your enemies, stuff like that. One thing that is by no means yet a consumer technology is the internal version of that, the invasive version, which is called deep brain stimulation. Basically putting electrodes inside the brain and not having to go through the scalp, not having to go through the skull, getting up close and personal with the neurons and giving them some extra voltage. This has been done in cases of severe Parkinson's, and they've seen definite benefits, although the question to this point has been, why are those benefits happening? They see the results, but they're not exactly sure what's going on. This past month, Medtronic released its first deep brain stimulators that have recording functions along with the electricity distributing electrodes. So these first two human implants were done at the Stanford Hospital and Clinics at the UC San Francisco Medical Center. This is called the Activa PC+S deep brain stimulator system, and we'll see what the results are very soon. I don't think it's going to get to the point where we're going to be walking into our nearest Radio Shack and getting intracranial appliances installed anytime soon, but it's interesting that this technology is advancing at the pace that it is. And obviously, even compared to things like fMRIs and all these real-time imaging systems that we can have to see what's going on within the brain as far as blood flow and things like that, being able to have recording mechanisms installed directly within the brain is going to give sort of an all-new level of clarity on exactly what's going on as these deep brain stimulators are applying current. So, way to go, Medtronic.
Smart Drug Smarts.
And in less national level news, another couple of reviews on iTunes. James Peak says, excellent podcast with 5 stars. Thanks for the great work. I really enjoy the podcast and the information you provide. And American University LT says, I think this podcast is great. It looks at interesting and controversial issues that are current, very important, and fascinating. The host often finds excellent experts and has gotten beneath the surface on some interesting issues. Thank you very much to those who leave reviews on iTunes. It definitely helps sort of push us up in iTunes' own internal recommendation algorithm. So when people are looking for things to listen to, they find out about Smart Smart Drug Smarts more easily. So we're about to jump into the main interview now. This is Dr. Fernando Gomez Pinilla of UCLA and the Neuro Life Lab, as we mentioned, talking with him about what we can do both dietarily and as far as exercise and lifestyle habits to improve our cognition. Unfortunately, we had some bad audio at the very beginning of this telephone call that we had to snip off, so we're going to kind of drop you in the middle of things. I mean, not really in the middle of things, but you missed about 90 seconds of good stuff at the beginning that you'll just have to imagine.
Smart Drug Smarts.
My main interest has been in terms of science to learn how what we do on everyday life can affect the brain, and even going beyond that, isn't it can affect the resistance to diseases and many, I would say, neurological problems. And basically, we originally described that exercise would affect learning and memory capacity in the brain. Also, that this could be through very specific pathways in the brain that very important for the processing of cognition in the brain. So we have been actually documenting this more and more, and also this theory has been growing to learn more how this exercise can affect the brain. And as part of my interest has been also foods, sleep, and even something related to stress, isn't it, how this can affect the brain. So then later on, we started connecting this to the effect of foods, isn't it? We have found what type of bad diets can reduce brain function or diets that can increase brain function. And we have been also elaborating on some type of theory by which all of these modalities can interact with each other in order to affect the brain. So the idea, isn't it, for example, how exercise can interact with foods, isn't it, or sleep in terms of mechanisms in the brain, and also try to have general ideas, isn't it, to tell people what to do.
One of the things that I read about you was that your studies have said that the effects of diet on cognition can be so profound that the mental health of entire countries may be linked to them. I'd love to hear you elaborate a little on that, on what you've seen sort of on a national level from how different countries, their populations eat, and what that means for their cognition overall.
This story about the effect of exercise or foods in the brain is nothing new. Actually, what is new is all the science behind that. Now we can know how to use the power of exercise or foods. But this has been, since men and primates actually, or even beyond that, isn't it? I would say millions of years of evolution. So now we have a pretty good idea, isn't it? And actually, for anyone who visit the Smithsonian, for example, in Washington, or you will realize, isn't it, that the locomotion was so important for species survival and also the type of food. And we know exactly how these interact in order to have type of brain that we have today. So basically, the brain that we have actually evolved around, certain type of foods, isn't it, also energy to power all of this reaction as well as exercise. So the exercise actually was very important in terms of evolution of the brain. Is very well connected to cognitive function, because actually it's very logical, isn't it? The animals that they didn't develop this capacity, or the species that didn't develop this capacity, they were not able to compete. Based on all of these theories, you might realize how important is exercise and the right food in our days, because the brain that we have today, I would say, is the same brain basically that we have 1,000 years ago. So the main difference is the environment have changed dramatically, particularly in Western society, in urbanized societies like Los Angeles or many big cities. The people don't walk, isn't it? They drive everywhere or use elevators.
Yeah, they even had that song in the 1980s that nobody walks in LA.
Exactly, yeah. And that's not only in Los Angeles, some cities more than others. The same thing with the food we consume these days is kind of more fast food, that we are not thinking very carefully about the ingredients, or because people don't have time to be cooking. And in general, all of this has tremendous implications for the healthy stage of the society, because now we know, for example, in terms of obesity, in terms of diabetes, for example, obesity, United States is the number 2, used to be the number 1, and diabetes is the same situation, it's an epidemic now. So these are the huge implications in terms of the effect of exercise and food, and we have been working in our laboratory laboratory at UCLA trying to explain is how food and exercise can affect all of these pathologies, trying to develop some type of general hypothesis that we can explain all of these problems.
Yeah, and I think probably trying to get a quantitative measure on, not just that a good diet is good for you, but exactly what within a diet you should be trying to minimize or maximize, how much is enough, things like that. I know that you're a major proponent of fish in the diet, omega-3 fatty acids and DHA in particular. Can you talk a little about your studies there?
We have been working on the effect of omega-3 fatty acids, particularly DHA, and we have found how important they are. All of this is very logical because people used to say brain food for the brain. However, the omega-3, particularly DHA, is actually brain food, I would say literally. DHA is part of the membranes in the brain, our layer of cells. All cells in the brain are surrounded by membranes. And the
right,
DHA,
so it's a major literal building block, like a significant portion of the brain's weight is made up of this stuff.
Exactly, yeah. So there is like the bricks of the brain. So basically, for a functioning of the brain, DHA is so important, and we have found that DHA is very important for learning and memory, also for keeping some emotional stage on the brain, is kind of reducing depression, anxiety, and also working in animal models of neurological disorders like brain trauma. We have found how important is DHA to reduce the effects of brain trauma. So as I said, DHA is so important that practically every function that we are thinking about the brain, they are related.
Now, is it accurate to say that DHA is something which can only be gained through the diet, that it's not something that humans have a way of metabolizing on their own?
The brain and the body actually has the machinery to make DHA, but it's not very efficient. So that's why most of the DHA that is functional has to come through the diet, and we are very dependent on diets that have the omega-3, which are precursors for the DHA. So particularly DHA is prevalent in fish, particularly salmon. So in terms of, as I said, brain performance and body function in general, I think we are very dependent on this diet.
Here's one thing from my own personal history. I was a strict vegan for almost 7 years. I'm not anymore, but during that time I was eating no animal products, certainly no fish whatsoever. I'd wonder in retrospect, are there ways for vegans to get DHA precursors into their diet through other means, or are you really sort of starving yourself if you're going on a strictly vegetable-based diet?
Yeah, I think we are learning also that by combining certain diet or by having some particular nutrients, we can actually support a synthesis of the DHA in the body at least. So we know now, for example, turmeric, which is a part of the Indian diet actually, or a curcumin from the plant turmeric, actually helps to synthesize DHA in the body. So that's
interesting because a large proportion of Indians are vegetarian.
Exactly. So that's very important, and actually that was one of the main motivations that we had thinking about the Indian population, is that they are vegetarian. So the question is how they really make it to get this DHA. So that's one of the ways to do this, and also we are looking at the effect of exercise. And actually, we have reported scientifically that exercise also contributes to maintain the levels of DHA and other omega-3 fatty acids in the brain. So as I said, which actually there are alternative ways to remain functional, and also the message is we don't need to rely in only one particular component. So we need to be thinking actually combining different modalities to stay healthy.
Sure. For me, it seems intuitively hard to imagine that with a proper diet and all the pharmaceuticals under the sun, still without moving your body in the way that we're evolved to be physically active, that you could possibly have things functioning optimally. It doesn't seem realistic to be sitting in a chair for 16 hours a day and sleeping the other 8 hours a day and think that something's not going to go wrong.
Yeah, exactly. So that's certainly one idea which is important, I think, to emphasize to the community, because the tendency of people actually is to remain sedentary or do very minimal exercise or abuse in many ways. And there are many pharmaceutical companies that support that, isn't it? Because many times there is a lot of hype that there may be a drug that may simulate the exercise or something, isn't it? It's important that people understand, isn't it, that these necessities are so huge that it's very difficult to have it with a single drug.
Yeah, yeah. I think, people are lazy now by nature. We always have been lazy. It's like if you're an animal in the wild, you're not expending energy just for the sake of expending it. But on the other hand, it used to be that you had to expend energy if you wanted to bring your meal home for the night. Now we live in a society where that requirement isn't there, but we still need to somehow sort of work around our natural laziness to make sure that, we're getting at least a comparable amount of exercise to what we might have gotten in the wild. One question that comes to mind, obviously there are many different types of exercise. You could do everything from heavy duty weightlifting to, marathon running. Those both get you in shape, but in very different ways. And I wonder how your studies have shown the different types of exercise might have similar or very differing changes to the way the cognition works.
Yeah, I think in general, everything helps a little bit, but certainly what's the best is the aerobic exercise. So it's like running seems to be very good, and any exercise that it has some cardiovascular component. In terms of, for example, weightlifting, many times studies use that as a control in order to show the effects of running, for example. So what I'm trying to say that the best actually, as I said, any type of aerobic activity. And most of the studies in humans, they point at least running like 30 minutes per day for 5 days per week. So that's kind of the basic dose of exercise.
I know that for cardiovascular exercise, most people think I'm either exercising yes or no. It's a on switch or an off switch. But probably a big component of that is what heart rate you're actually running at. If you're running slowly, you might be maybe at 60% of your heart rate maximum, whereas if you're running at a full sprint, you might be 90%. Is there sort of an optimal place where people should be aiming as far as during their aerobic exercise, just how hard they should be pushing themselves?
Yeah, I think every person has a different performance, and I think we need to think about, I would say, the capacity of each person. But for what we have done in terms of the experiments in animals that we can control that, basically the idea is the more efforts that we spend doing exercise recruits more neurons, which are the main nerve cells in the brain and spinal cord. So, for example, we run in a flat surface or we run uphill seem to be more beneficial in terms of the effects. And also that can be also done in terms of program. The treadmill is a need to go
a different incline.
Yeah, the incline, and also try to push yourself to work at the maximum of your capacities, and it depending, as I said, on the conditions of the individual.
Gotcha. So it should be a pretty strenuous session then, and not necessarily a light walk. You should be breaking a sweat and feeling yourself breathing heavily, that kind of thing.
I think so. Yeah.
So what would some of your main recommendations be then? I'm not sure if you had children or a young person coming to you that basically they're a fresh brain. They can be doing anything with their life and building their daily habits in any way they want for optimal cognition. What would be some of the key things that you would give to them as bullet point recommendations?
Yeah, in terms of exercise, I think is to have developed some type of methodological behavior, isn't it, in order to make sure like you have some activities during the week, trying to make it on regular basis. But thing which is very important is there was a professor here that was trying to build a national campaign about this, to use exercise on your daily life in ways that a lot of people, I would say, don't do it. For example, when you come to work, you have to go to the third floor, where is your office. Instead of using the elevator, use the stairways, for example. I mean, doing those that apparently they are minimal things, they may be very helpful, isn't it, to have some type of, I would say, general habit in order to have activity. So I would say that's one of the things. And the other things in terms of eating properly. So we have been working lately, and we published some very provocative studies in terms of the effects of sugar on the brain, which actually seem to be very bad in general. And I am mentioning this because at least in the Western society, we consume too much sugar, more than we really need. And practically all the type of freshmen, isn't it, they have high concentration of sugar. And if we added these to many other things, can be very problematic. And that's some...
Could we clarify that real quickly? Because I know that a lot of people, when they hear sugar, then sometimes they extend that to think, well, fruits are sugary, so I shouldn't eat fruits and things like that. But am I correct in thinking that you're talking more about processed table sugar, sort of white granulated sugar, that kind of thing?
Yeah, that's what I'm talking about. And also I'm talking about a refreshment, that the kind of soda, they have a high concentration of sugar, a Pepsi, Cola, Coke. One of the problems also, they have high concentration of high fructose corn syrup, which actually has has at least 50% fructose that seems to be very problematic for the body in general, for obesity and also for diabetes. So basically, I think that's something very alarming, trying to control the ingestion of sugars, isn't it? Try to reduce sodas or try to choose sodas that have low contents of sugar, isn't it? Which actually exists. For example, Coca-Cola, they have this Coke Zero, for example, that doesn't have sugar, for example. And I try to at least control that. Another thing in terms of food that we know, and many people actually have studied this now, the effects of saturated fats. And a lot of the junk food that we consume today has a high concentration of saturated fats. For example, hamburgers in many fast food restaurants.
Yeah. Basically, that's talking a lot about red meats and things like that, whereas fish meats generally are not, it's not the monounsaturated fats. Monounsaturated fats is vegetables, but fish meat is more unsaturated fat. Is that correct?
Yeah, unsaturated. So I am talking about the saturated, like fat, like from meat or the type of fat that we find when we eat a hamburger, for example. And normally this fat, you can recognize it when get cold, get very solid. Yeah, so for example.
Right. You look at your leftovers in the refrigerator and you've got sort of crystallized waxy fat that's floated to the top. That's the stuff that you probably don't want to be eating that food to begin with.
Exactly. And we don't realize about this because when we go to the restaurant, it smells so well and it's hot and everything, very soft. But when we put it in the refrigerator, you cannot eat it later on.
Yeah. So here's a question that I had. Reading about your research, there's a lot of reference to BDNF, which is a brain-derived neurotrophic factor. This sounds like it's something that you keep coming back to in your studies. Can you tell us a little about, just for a lay audience, what BDNF is and why it's so important to cognition?
Yeah, it does. I would say it's one of the most important molecules in neuroscience these days, and I would say for the last maybe 15 years, because it's a molecule that, for one thing, is very important for memory. We know also that it's very important is to have proper levels of BDNF in order to reduce emotional disorders. And when we look at this molecule in the brain, it's very well localized to areas which are very important for the processing of cognitive function. For example, BDNF is very important for the transmission of information across nerve cells. And also in terms of all what we have been discussing, this BDNF has proved to be incredibly important because in addition to what I said in terms of learning and memory and connection between cells, now we know that energy is a very important modulator of BDNF, and also BDNF seems to modulate the processing of energy in the brain. So,
energy in the form of glucose?
Yeah, in the form of glucose and also in the forms of how the brain releases energy from different compounds. So BDNF is very important for the function of the mitochondria. For mitochondria, the mitochondria, we know, is the powerhouse of the brain. So the BDNF is very important to modulate the function of the mitochondria. And that's very important because for the research that we are doing, as I mentioned to you already, the energy consumption and modulation of energy has been so important for evolution of the brain, because that energy isn't it like we can see these days? We know that we have an energy crisis in the world in terms of
ever-increasing demands on our fossil fuels and things.
Yeah, so then practically the whole world has mobilized in order to have more efficient cars and that can use less energy and everything. So the same thing with the body and brain. So it was very important during evolution, isn't it, to have efficient brain cells that can work with low energy, and basically the processing of energy has been very well connected to cognition, cognitive function, learning and memory, and that's how it's important BDNF for all of this, because the BDNF seems to be one of the molecules that it has been in between all of these transaction of energies. We also know today that exercise actually elevates levels of BDNF in areas which are important for cognitive function. So we also know is that food foods like the one that we discussed, like DHA and omega-3 fatty acid, also an important stimuli for the production of BDNF. So that's why, as I said, this molecule has been extremely important in all of this understanding of the effect of foods and exercise on the brain.
For some of these things that we've talked about, like DHA and or turmeric in the diet and curcumin, is there sort of a sweet spot that you find in the diet where, you know, it's just the right amount, but then going beyond that can have negative effects? Or are these kind of things like where if you add more, your body's just going to kind of ignore the rest or not metabolize the rest, and you don't need to worry about having, for example, too much fish oil in your diet?
There has been some controversy about the fish oil, but in general, it hasn't shown to be deleterious if we eat it in high concentration. There have been a couple of studies in people have argued that can be a problem for a prostate cancer. However, there have been other studies saying completely the opposite. But if I have to give an advice, I would advise to go for the whole food, to eat the fish. And because I know that some people actually like to depend too much on drugs that contain fish oil or DHA. And we know now that up to 10 grams of DHA per day can be fine if you eat it in terms of a drug. And maybe you go more than that can be detrimental. I would say the average consumption that can be helpful, we know now that it's around 2 or 3 grams per day. It's for people who prefer to have the capsule. However, as I said, I prefer to have the whole food. You need to have the fish, particularly salmon, the more than you can.
Not to mention the salmon tastes great.
Yes, particularly since I mentioned curcumin, the curry salmon is very delicious.
Well, thank you very, very much. A lot of really good information there. Is there anything else that you'd like to circle back to and talk a little bit more about, or interesting tidbits you'd like to drop on our listeners? And I guess, you know, the one other question I've got is, since this podcast is really mostly dedicated to artificial ways of enhancing cognition, what are your thoughts on some of the high-tech, non-natural things that people are doing nowadays to try to have cognitive benefits?
I am cautious about non-natural devices. Some of them can be useful for people who have actually some type of impediment. I mean, they have problems in it. For example, people with reduced mobility, for example. I mean, it's understandable that prefer to go to drugs or some type of stimulation. But I think it's biology and nature have proved that the most effective way to use the way that Mother Nature has taught us to perform well. I mean, indeed, as I said, the body that we have today was built by nature. As I said, locomotion and foods, and this have taken millions of years. So all the genes that we have today have been programmed to respond to nature. I mean, that's no question. So, and I think that is the most effective way. And I would prefer to go that way first. As I said, if some people have some problem, physical problems or something, you can think about other ways, but I think that's the most effective one.
Yeah, that's sort of something that we've come back to again and again on this show is I feel like the easy wins for most people are to remove toxins from their diet and to do the things that are, a lot of people are undercutting what their cognition could be versus a normal baseline healthy human. And so, like, to try to bring yourself up to that baseline first before, you know, using artificial means to go beyond that, I think is probably pretty solid advice.
I think so. Yeah, I think so. So we need some culture about this. Hopefully there can be some improvements in the future, isn't it, in terms of education, because we have discussed this topic in many scientific meetings, and most medical schools, for example, they don't provide any teaching to the new physicians how to use the type of things that we have been discussing. So
I've heard that also, that there's so many unanswered questions on what correct nutrition is that most people getting their MDs really don't have any sort of nutritional training, because it's still kind of uncharted territories.
So in science now, for example, American Physiological Society and some other, so we have some type of a slogan like exercise as a medicine or a food as a medicine. And I think that's we need to learn more, isn't it, how to educate the people that can educate more people in how to proceed in terms of a healthy body and mind.
Is there one thing that you could say that most neuroscientists are aware of that the general public has no idea about, that, you know, if you could drop one kernel of wisdom from, you know, the collective wisdom of neuroscientists into the general public, what would that one thing be?
we know these days, for example, about the sugars. That's something that is the connection between many metabolic diseases and cognition. That I think people are not very aware how pervasive can be, isn't it? To have a high consumption of sugar maintained for a long time. That's, I believe, is not very well understood by society, because the consumption of these sodas is incredible. I mean, and I am aware that some people, they just don't drink water, for example. They just drink sodas the whole day. Or
I know there's some parts of the world also where it's cheaper to buy soda than it is to buy bottled water. And in parts of the world where getting clean water isn't necessarily as easy as it is in America and some other first world countries, the choice between a cheap Coke and a 40% more expensive bottled water. Well, people, they don't have a lot of money. They might go with the Coca-Cola, but I mean, it's really unfortunate.
Yeah, and I travel a lot around the world, and I've been seeing all of these problems all over, and even in places that you wouldn't expect. For example, Japan now is getting very concerned in terms of incidence of diabetes, for example, and obesity, and countries in South America, for example, like Mexico now today is number one in obesity. For example, I was in a meeting in Mexico a few months ago that they were talking, isn't it, that there is a huge migration of people from the countryside to cities, and what has meant in terms of the increase of diabetes in the population, because the people have to change their diet and habits in general. So, I mean, it's something that you see all over the place. Even if you go to Northern Europe, that people are supposed to eat better than other places, and they are also complaining against the invasion of fast food restaurants also.
Yeah, well, I mean, the unfortunate thing is that there's, scientists like yourself that are working on what people can be doing to increase cognition in the brain. There's scientists that are working for McDonald's trying to figure out how to make the food as addictive as possible, like literally addictive. And, they're very smart scientists also. And so it's something where, eating that kind of unhealthy food goes from something that maybe you would do on, once or twice a month to once or twice a week to a daily habit for people. It's kind of nefarious.
Yeah, and that's what seems to us about what we know that people might not know. That's another area, the food addiction, that these days actually we know that is a reality, that the pathways in the brain that are related to, let's say, what we knew about drug addiction, isn't it? They are very similar to the pathways in the brain that regulate the food addiction. So basically, it's very easy to get addicted to some type of foods, and also the effects seem to be very pervasive. And for example, I was in the last meetings of the Society of Neuroscience that was in San Diego on November, and there were several studies actually discussing now, for example, like the risk for diabetes that we have today may have been because our grandparents had certain type of diet.
Wow, that's fascinating. Thank you very, very much for your time on this.
Thank you for having me.
Smart Drug Smarts.
Alrighty, so thank you very much to Dr. Gomez Pinilla for that conversation. I guess if you were to distill all that down to a quick takeaway, maybe it's, jog to the supermarket, buy yourself some salmon and turmeric, and come back and cook yourself a nice meal. Seems like all of those things can only be beneficial for your brain. And another thing that could be beneficial for your brain, as we've talked about a little bit in past episodes, and hopefully we'll dive into more because I think sleep science is super interesting, but as hinted at earlier, the Ruthless Listener Retention gimmick is going to be about naps. So let's do that.
Smart Drug Smarts. Ruthless Listener Retention Gimmick.
So Lifehacker recently ran an article on how long to nap to get the biggest brain benefits. And this was pretty good for people like me that like taking a midday nap to kind of reboot, recharge. And the question is, if you're going to settle down for a nap, how long do you want to set your iPhone or whatever before it rings and wakes you up and gets you back and hit the ground running again? Turns out that for a quick power boost, 10 to 20 minutes is best. It's enough to get you a little bit springier afterwards, but you're not actually dropping into full REM sleep, so you're not going to kind of have that groggy feeling when you wake up. 30 minutes plus, you kind of enter the danger zone where it might take about 30 minutes after you wake up before you have sort of shaken off the grogginess and feel as alert as you should, and maybe as alert as you did even before the nap. So there's definitely kind of a 30 to 60 minute danger zone there. At 60 minutes, that length of nap is ideal for improvement in the remembering of facts, faces, names, things like that, but you still might have a little bit of grogginess upon waking. And then if you go a full 90 minutes, you've actually gone what for most people is a full sleep cycle, meaning that you've gone all the way through the lighter and deeper stages of sleep, including REM. And this leads to improved emotional and procedural memory, things like riding a bike, playing a piano, and creativity. This is the length of the nap that typically avoids sleep inertia, making it easier to wake up because you've gone, again, all the way through that 90-minute cycle and sort of popped out the other side in the ready-to-wake-up phase.
Smart Drug Smarts, the podcast so smart, we have smart in our title twice.
Okay, so one last thing on the way out. Last week in our listener retention gimmick, you might remember we talked about fan death, that weird belief that many people hold in Korea that if you go to sleep in a room with an electric fan running, that you will die. And I asked you to think about what other equally irrational, weird beliefs might you have, might I have. I mean, I don't think there's probably no person in the world that doesn't have something that they believe that, which is completely ludicrous. But anyway, I got some interesting emails in response to that. I think the one that I'm going to cite here, because it's holiday themed and it's December 15th as I record this, is from a listener named Scott who said, how about the cutting down and killing of thousands of trees for quote unquote decoration, just so we can watch them die in our living rooms every Christmas? Hopefully that's not too much of a bah humbug for everybody. I'm going to try my bestest to get one more episode out before Christmas time, and I think I might actually succeed because we've got one interview scheduled in just a couple of days. I'm really going to try to make it an early New Year's resolution to get these episodes out once a week-ish or so, maybe 3 a month. Maybe that's enough of an improvement over my lackluster performance this year. Thank you very much for listening till the end of this episode. This is the end. If you liked what you heard, please recommend this podcast to your friends and leave us a review on iTunes. The show notes for this episode will be online at www.smartdrugsmarts.com, including the links to everything that I've talked about here. And I will be back at you very soon with the same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.